about the Ghost, which is a new proxy implementation that we wrote. It's just a small tool that we need, and we wrote a paper for it. So it's not a big deal, but it's something we use, and it may be useful for others as well. So the idea is, what's a proxy? We all know it's in an object that proxifies or that intercepts the methods that are received from another object, which we usually call a target. For what I would tell that a target is the object that you proxify. The client is the object that was using the original target object. The proxy, the interceptor, which is what we commonly know as proxy, that is his job is to do the interception, to intercept the methods. And finally, they call the handler, that it does something with that interception. So it could be, for example, for logging, it could be for checking if certain securities are correct or not, etc. So if we do just for a simple example where we want to intercept methods, log and forward to the target object, what we usually do is we create an instance, for example in Mariano, we create a proxy, we proxify it, and then if I say username to the proxy, it should answer Mariano. So that was basically what the proxy does. It intercepts the method and it forwards the message. So if we see the transcript, we should see that the method was intercepted and it was forwarded to the original object. So we see basically, and somewhere we have to define what we do with the interception, which in this case is to log and to forward, and this is the original method of username. Is that clear? That's normally clear. Okay. So one of the things that we usually face when we are getting this proxy is whether we want or not to be option replacement between the target object and the proxy. Why? Because if there is option replacement, what we all call like the become, it's extremely more complex than just getting an instance, because I can just, I don't know, so for example, if we are in remote processing or remote method invocation, I can get a proxy and I just talk to that proxy, but I don't replace a target with the proxy. So in our case, we want to deal correctly with option replacement, and this adds a lot of challenges that I will show you. So in the traditional and naive and common implementation of proxies is to have a kind of a minimal object, which could be, for example, in firewall script is the proto object, which basically understands a few methods, and then you subclass with your proxy, and you basically implement the does not understand, which usually does something before or something after, and in the middle it forwards the message to the target. This is the most common implementation. But let's see what happens. For example, if I have this example, I create an instance and I ask the identity hash to the original object, and then I ask it again to the proxy instead of the target, what will we have in the proxy in the JavaScript? In that case, we will have two different things. So what's happening is that we are only intercepting the methods that are understood. The rest of the methods are not being understood, and that leads to a lot of big problems. For example, imagine that somewhere in the code we are doing, we replace an object by a proxy. For example, if we do then identity hash equal another object identity hash, this will answer something different. So the code executor will go for different paths. So it's really bad to have methods that you cannot intercept. That's one of the reasons. The second reason is, which is most theoretical and a little more complicated to see, that for example, imagine this example, I do the same, I create an instance and I proxify, and then I set a method that doesn't exist. This will try to intercept the method and to forward to the target, but I don't want that in this case. In this case, I want it does not understand, the regular one. So, there are much more examples. For example, if I do proxy new whatever method that doesn't exist, it will try to forward it as well. So there are more situations where the base level of the error handling is mixed completely with the interception. And that is also a problem that we So the problems are that the not understand cannot be trapped. So if I send an object that not understand, it is not intercept. In fact, it is execute, and then it handles the interception. So that's quite bad. We are mixing the handling of the error handling and the procedure to intercept methods. When in this case we are only able to intercept only the method that we do not understand. And finally, and this is something I think it is very important, that there's no clear difference between the proxy and the handler. It's always the same. You usually implement just proxy and does the both things, the interception and handling it. So that's why we say that this approach is not stratified. Some may think that just subclassing from nil instead of subclassing from production solves some of the problem. In fact, it may solve the problem of that you cannot intercept the method that you do not understand. But in fact, you cannot just subclass from nil because you will need to implement several methods because the system cannot just work with node methods, so you will need to implement a couple of methods. And nevertheless, the mix between the separation of constant is still missing. There's no difference with that. So, even more problem if we do the become, if there is option replacement between the proxy and the target. If we, for example, if we proxify a class, this will simply crash. Simply. Because if I send a message to an instance and whose class is now a proxy and not a class, when the VM does the method lookup, it assumes that the method dictionary has to be the same on the slot of the, so boom. And something similar happens with the compiler method. So for example, if I proxify a compiler method and I send username, I will raise that having that compiler method and not understand wrong within. So that's why we say that this solution is not uniform. That's what we call uniformity. So that's why we did Ghost, because for my PhD I need a really good toolbox for proxy where I can proxify almost everything and do not crash in the VM. And I don't want to mix the nodes, and I want to be something completely stratified. So we start with this. The name is because Ghost at the beginning we used to focus on transparency and lightweight, so Ghost are both. But then we prefer to focus on the uniformity and the stratified. So the name is not accurate now. But anyway, so the hooks that we use proxies are really dependent on the VM and in the language. So it's really difficult to find a proxy solution that works out of the box with different languages and different environments. So in this case, we use a couple of hooks, but at least none of them are implemented by us. I mean, they are provided directly by the Squid virtual machine, so we didn't need to touch the VM. Basically, we need the become to just swap the proxy and the target. We need the adopt instance, or what it was before code, change class of, we just change the class of an object. The run within, that I will explain now, it just means to be able to use objects as methods. And finally, and this is the most complicated, that I will explain, and this is the base of Ghost, is the trick of the cannot interpret when the method dictionary is nil. I will explain. So the object as method basically is that in SquidVM you can put in the method dictionary, you can say method dictionary at a symbol username, put a special object. A regular object, whatever, not necessarily a compiled method. So when the VM resolves the method lookup, so I say target username, the VM will check, oh, this is not a compiled method what I have in the method dictionary, it's something else. So in that case, the VM sends the method run a selector with an array, which is the argument, in a receiver. So we can take our proxy for compiler for compiler methods, and we can implement this method, and then we can intercept as well method execution, which was something that we were needing in our case. So this is object as a method. Okay, so far so good. Okay. Now this is the most the base of the method, the cannot interpret. The idea is the following. We shall do. Imagine that I have this class, proxy trap, which has the method dictionary in name. Okay? And I have a proxy which is instance of that class. Okay? If I send the message username, what will happen is that the VM will do the lookup of the method username in here. The VM checks that the method dictionary is nil, and what it does in that case, it sends to the receiver, it sends the method cannot interpret which receives an instance of message, but starting the method lookup in the superclass. So this is the trick. So I will explain again. When the VM notices that the method dictionary of a class is nil, it sends to the receiver, it says cannot interpret, it sends to the receiver, but starting the lookup in the superclass. Okay? So that lets us implement here the cannot interpret, and that way we can intercept messages. So how this works, I can explain better. These are our basic model. So we have our proxy class, which usually has a handler and a target. The target is the object that we want to proxify, and a handler, which is an abstract handler, and then the user has to provide a complete implementation of a handler, which usually you check in handler interception and you do what you want to do. I mean, the client decides what to do with interception. And then this is the trick that the proxy trap is a subclass from this one. And this is the one that is the method dictionary in nil. So let's see how it works. I have this piece of code which I just create an instance of a user. I use the proxy for it, and then I say, okay, a proxy username. So what happens? When I execute this, what I am doing is, this is being in proxy class, okay? We are here. So I create an instance of proxy. I correctly initialize it with a target and handler. In this case, it's a symbol for what the handler, example, and the target. Okay? So I have an instance of proxy so far. Then I initialize the proxy trap class, which will set the method dictionary to nil. And then what I do is I adopt the instance of the proxy that I just created to be an instance of proxy trap. So what happens is that a proxy, at the beginning, a proxy is an instance of proxy, and it has the two instance values, the handler and Mariano. When I do it initialize, this will set the method dictionary in nil, as I explained you. And here is the trick. The dot instance makes this proxy now to be an instance of this instead, which is the trap. So what happens next is that when we send username, the VM will do all that I have already explained. So it will check that the method dictionary is nil, so it will send cannot interpret to proxy. So that's why we can finally, it follows all what I explained, so I can finally implement cannot interpret in proxy and do whatever I want. In my framework, I verify the interception object and I forwarded it to the handler. So then you can customize the handler and implement whatever you want. For example, in the case of a symbol for what handler, you can just you ask to the interception, you can ask the message, and then the selector, for example, or whatever. So, in conclusion, the traditional proxy implementation uses that Danoka cannot be dropped because it is messed up with the base level application. In Go, if we send cannot interpret, it will be intercepted because the method dictionary is still in. I mean, who cares which was the method that was received? So it let us define in the handler side which method do we want, because maybe there's a method that we want to intercept in the handler, but we decided from the handler side. From the security point of view, it's even cool. So there's no mix in Go between the handling and the interception, between error handling and interception. With Go, we can implement all methods, I will show you next slide, which in the tradition we can only implement those that we cannot understand. And finally, that we have a clear separation between proxies and handlers. So this is why we say that Go is stratified. We cannot intercept all methods, that's the truth, because there are two kinds of optimization that happens in most small jobs. One, if you know those optimizations done by the compiler, and it's true, if false, that they are never executed because they are automatically replace it by special bytecodes from the compiler. So if you do if false, it just do two jump bytecodes. So in that case, we cannot intercept them. And then there are some other which are shortcut bytecodes. The VM doesn't do a regular set, but instead it is associated special bytecode. This is the list we have in Faro, but some of them will fail if it's not what they expect to be. So, for example, if the plus expect to be two small integers, so it's not one integer, it fails and finally send the message. So the only two real problem for us is equal, and plus, and all those optimization by the compiler that we cannot do more than just disable them, but that causes other problems. So we can also deal with proxy for classes, but it is much more complicated to explain. So I want to explain it. The only thing I can tell you is that if you see, we have a special proxy for class, which has the three instance variables, superclass, method diction, and format, and that way the VM does not crash if you proxify a class. And even more, but it's difficult to read, but if someone wants to take and explain you, we can intercept them if you send a message to an instance of a class that was proxified, we can intercept that as well. So we do not only intercept method sent to the class instance, but also to the instances of the class. So it's complicated. Anyway, so the same happens with the, sorry, I want to go fast because so the same happens with methods. So for example, with method, we can send both things. So for example, if I send the message which compiled method was replaced by a proxy, it will be executed like a regular message because I'm sending a message to the compiled method. So it's like regular message. But if I execute that, so in this case I am executing a compiled method which was proxified, and this way we can also, using the object as method trick, the run within, we can handle this. So we can also intercept, not only we can intercept the message received by a compiled method, but also when a method is being executed. That is with the run within hook. Okay, so the idea that code is uniform. Because we can deal with classes and compiling methods as well, but it's not completely uniform because, for example, if you proxify a process, the VM will crash because there's still more objects than just class and compiling methods that require specific proxies. But we didn't need it so far, so we didn't do it. But we need to do the infrastructure. So if someone needs a proxy for process, it can create a subclass and correctly handle with it. So that's all. Okay, there are a few that we try to use as less memory as possible, like proxy and compact classes, and we can have a list of messages that we do not intercept, so the handler answers itself, so that can be easy for debugging, and we can disable them. So that's cool. And okay, the conclusion is that with a little bit support from the VM, which is this just check of the method dictionary, we can have a much cooler proxy implementation. So we think it's not that complicated to implement in the VM side, and I think it's worth it. So that's all. The code is nothing really important. Here are the links. If you want to see the code is coded in here because this is part of my PhD, which is called Maria. But anyway, here you can see the description of the structure, and that's all.
I didn't really understand the cannot interpret. Is that something that's already in the VM?
Yes, it's already in the VM. I just use it for this specific usage.
How did you find out about
it? It's a good question. I don't remember exactly because it's not a very known issue. In fact, Lucas Remedy was one of the reviewers of my paper, and he told me I was not aware at all about this. And I think it's amazing. I mean, there could be better ways to handle with proxies from VM side. But this is just a simple approach that I think it's more or less good. I don't remember exactly how I come with that, but then after I thought about this of putting the subclass and changing the subclass, and I use it for proxies. Yes?
Are
Are you aware of the work of Adrian House that he had when he tried to get your machine with
the aliases? With the aliases.
Yeah, with the aliases. I was just wondering, actually the work of Meta and Charlie with other policies.
Yes, yes. It's in fact one of the future work that I put is like kind of using. What he has is a work that doing in Lilo and Nonlinear that is to create kind of intermediate object. Intermediate object. I mean, objects do not point directly to other objects, but instead to an intermediate line that points to the original one. So we can use that object as a proxy.
But do you think that, like with Ghost, we can do the same thing that Adrian did? Is that modifying the VM?
No, because what element was much more low level, was much more deeper because you need to create aliases for each of the change, for every method received, for every message received by an object, you have to create an alias and keep a lot of state to be able to come back with the debugger. So it was kind of much more complex. But having intermediate object that he did, maybe a possible use is for proxies. That, yes, for sure.
I mean, it's a performance issue.
Yes, it's a performance because of the model for the GC. Because you have to a lot of
encapsulation policies.
Yes.
They use essentially 2 pointers for each pointer.
Yeah.
And you could of course do that with a proxy.
Yes.
But then every
yes, you will end up with
you have it almost every line.
yes. Yes. Yes.
One last question.
Just to be sure, so self-send and supersend are escaping the initial proxy.
That's a great question. With the super class, we had some problems. We found some solution, but we're all dirty. So far, I should check, but I think we didn't come with a good solution yet, because with Nuri we were discussing about creating another class where we can override, but we need to change the class of the original object, and that was not very cool. But yes.
Have you considered simply changing the VM so that you don't have to use all this proxy stuff anymore? Because the proxies, I mean, it's a solution I would use in VisualWorks because I don't have access to the VM. In Faro, you have access.
Yes, in fact, it's trivial. If for example, in the VM, if I go to the method lookup place and I can just check, okay, this object is a proxy, it's true, and that's extremely easy. I can do it in 1 hour. The problem is sometimes it is difficult to escape from being intercepted. Because in this case, for example, if then I put back something, it stops intercepting. And with the VM, it's more complicated. And another problem is that I can hardcode. For example, when I say, okay, this is a proxy. How do you know it is a proxy? Okay, I can assume that it's a certain class. Okay, I can only have one class. Okay, I store a list of classes that can be proxies. So, okay, I need, for every method lookup, I need to search in that. That will end up with an overhead penalty. Or I say, okay, I want to use a tag bit in the object header, so that I can tag that it's a proxy. We don't have more free bits in the object header, and things like that. But it should be doable. It's not that hard.
Okay, I suggest to move to the last talk. So it's